Welcome to our last video on the peripheral nervous system. I promise you the next lecture is shorter. We are now on to the lumbar plexus. We've looked at the brachial plexus in detail and the cervical plexus. The lumbar plexus, like the other plexes, goes from the anterior rami of spinal nerves. Now these spinal nerves are L1 to L4. Now it too is broken into an anterior division and a posterior division. So the anterior rami again merge together and they form these divisions. Now, some of the nerves of the lumbar plexus are going to go to the pelvis here. I care about two main nerves that come off it. The femoral nerve, that actually has a lot of different femoral nerves, like the lateral cutaneous femoral nerve, the femoral nerve proper, but we're just going to call it the femoral nerve to be easy. And it goes to the anterior compartment of the thigh. So it goes to the quadriceps group. So here is the femoral nerve, and it's going to the quadriceps. The other nerve that comes off it is the obturator nerve. It comes from the anterior division, and it's going to go through the obturator foramen, and it goes to the medial portion of the thigh. So that's going to go to the adductor group and the gracilis. So femoral nerve is going to go to the extensors of the anterior thigh. The obturator nerve goes to the adductors. So the sacral plexus. The sacral plexus gives rise to the sciatic nerve, which comes out underneath the sciatic notch. Now in reality, if you were to cut this nerve on the cadaver, you would see that's actually the tibial nerve and the fibular nerve just wrapped together, and it's very superficial right here. Now, as it's going down, as the sciatic nerve is going down, it's going to innervate the hamstrings. So the semi-muscles on the side, the biceps femoris on this side. Now, as it gets here, it's going to branch. It has one branch that goes on the tibial side. What should we call something on the tibial side? That's right, tibial nerve. And then we have the common fibular nerve. It is going to branch to a superficial and a deep one. So we have the fibular nerves on the fibular side. So the sciatic nerve is going to innervate the hamstrings. Then it branches into the tibial nerve. And see, it actually goes all the way over the malleolus. Sometimes plantar fasciitis is actually an inflammation in this nerve and not the fascia. I have been told. Don't quote me on that one. And the fibular nerve is going to go to the lateral side and the top. So, intercostal nerves. They arise from the rami of T1 to T11. Don't ask me what happened to T12. I do not know. And they travel between the ribs. So here is our anterior root, posterior root. They form the spinal nerve. There is our posterior ramus there. And here's our anterior ramus, and it just continues along between the ribs in the intercostal muscles. And it innervates the intercostals, and it goes to the skin around the outside. Very exciting. So, which order is right? Trunk nerve division cord? No. Root trunk division cord. Let's see. Rad teens. It must be this one. So 2 is the correct answer. Nerve plexuses come from which rami? Anterior, lateral, or posterior? I hope you remember me saying anterior a billion times. It is anterior. Which is false? The ulnar nerve goes to the medial anterior compartment, the radial nerve posterior compartment, sciatic nerve posterior thigh, femoral nerve medial compartment of the thigh. Well, the ulna is on the medial side and it comes off an anterior division, so that must be right. Radial nerve comes off the posterior cord. That must be right. Sciatic nerve is on the posterior part of the thigh. So this one is the false one. This is anterior. That's the obturator nerve. That is medial, which is not part of the cervical plexus. Hypoglossal, remember it sneaks in, so it is. C1 to C3, yes. C4 to C5, oh yeah, C5 double dips. Silly C5. So the answer is 4. This is the brachial plexus. So we are going to look at the components of reflexes now. You'll study these in more detail when you get to physiology. So, a reflex is a rapid, involuntary reaction to a stimulus, either with muscles or glands. Now, a stimulus is required. So here we have a nail going in to the skin. Ow! Reflexes are a rapid, automatic reaction of muscles or glands to a stimulus. So a stimulus is required to initiate it. So here's a nail. It's going into the hand. Ouch! Now, it's rapid. It actually gets integrated mostly at the spinal level, unless it's something coming from the face. And it happens the same way every time. That's involuntary, no intent or awareness. So, a reflex arc is basically the neural wiring. It always begins with a receptor. That receptor detects a change. Ouch! There is our stimulus. The neuron is going to take the signal to the central nervous system, and it's going to go into the spinal nerve, and it is going to go through the posterior root to the posterior horn. Since this is a withdrawal reflex, there's an interneuron here. So since this is a withdrawal reflex, it is going to go to both sides. Since this is a withdrawal reflex, it is going to go to the anterior horn on both sides. And it's going to innervate motor neurons in the anterior horn. Now, the motor neurons are going to leave on efferent neurons on the anterior root. And it's going to go out. This one's going to go through the brachial plexus to the muscle cutaneous nerve, and it goes to the effector. Effector could be skeletal muscles in case of this somatic reflex, or it could be smooth muscles or glands in the case of autonomic reflexes. Now there's two types of reflexes. Monosynaptic reflexes just have the afferent neuron going through the posterior root. It actually goes all the way to the anterior horn where it synapses with the motor neuron going out the anterior root to the effector. These are the tendon reflexes. So you stretch the reflex, that's a monosynaptic. So usually when you go to the doctor's office, it's a monosynaptic reflex. Here's the withdrawal reflex. That goes on an afferent neuron through the posterior root to the posterior horn. There's an integration neuron that's actually going to junction with a bunch of efferent neurons. And that causes you to draw your hand away. So it goes on the anterior root and it goes out here.